Now, this is a pipeline or a flow diagram of a supervised learning algorithm, right? So initially we have some samples here. These samples means that we have a data set, and in that data set we have selected a portion of samples as our training samples, right? So for example, from 100% data set I usually select 70 to 80% of the samples as my training samples, and the rest 20 or 30% samples I treat them for my testing or validation purposes, right? So this sample means that we have a subset of portion from my whole data set. So in simple words, you can say that 80% of my whole data set makes these training samples, right? And we are having these training samples so that we can tell our algorithm that so that it can go through these samples and it could have an understanding that what kind of patterns or features these samples have, right? So the next step is that from these samples we perform feature extraction, right? So the features which are quantifiable, which are measurable, and which have some characteristics with some distinguishing characteristics, we our focus is to extract those features in this stage, right? So I gave you a couple of examples. Say for example, in face recognition application, my features can be facial textures, and for example in some other applications such as the weather forecast or stock market prediction, right? I can be looking into various landmarks which can help us to learn the underlying characteristics of these samples. So the feature extraction is a very crucial and important phase, and if these features are not extracted well, or they are not with enough distinguishing properties, then it will be a very difficult task. So this feature extraction step will result into a number of features, right? So depending upon the application and the data set and the size of the data set, we will have some large number of features here, and sometimes it happens that we end up with so many features which basically because having too much features, if they are not of good properties, for example if they have some redundant features or some features which are not playing a major role in classification or prediction, then sometimes we don't need those features here. And in such a case, you can apply some feature selection strategy. So you can insert another block here, and that block will basically select only those features which are enough with enough capabilities, right? So this feature extraction phase will end up with a number of features, and we can apply some feature selection strategy, and then those selected features or important features, we will feed those features to our machine learning model, right? So let's suppose for example we have a neural network here. So my neural network will basically be trained on those features which are extracted from my training data set or my training samples, right? So this will be provided to the machine learning model in an iterative way. The machine learning model will be going through each training sample and all those features in an iterative way, and it will basically, for example if it's a neural network, then it will be adjusting its weights, right? So adjustment of weights is the main goal in a neural network, because the final classification on is based on the values of weights. So along with all these things, we are also providing the labels of these samples, right? So in case of a neural network, these labels are basically helping the network to determine the error between the actual value and the predicted value, right? Because there will be a prediction from the neural network, and we will have an actual value here, the actual label of each instance, and then at the output layer we basically calculate the error value, and that error value helps to train this model or to adjust its weight properly, right? So to summarize, I can say that in training phase, I provide training samples along with their labels to the model. The model is basically being trained on the features which are extracted from those training samples, and then I will have a trained model which can be used in order to make predictions or classification. So this was the one phase which is called the training phase, in which we are training our machine learning algorithm. The next phase is the prediction phase, in which we use the trained classifier which we have trained during this training phase, and we want this trained classifier to predict the label of an unseen instance or an unseen sample, right? So now in that case, our input will be the rest of the data set, right? The rest of the 20% or 30% of the data set which we selected in for the prediction phase, and these two steps will more or less the same, right? So from each testing example, our algorithm will extract features, and it will have some distinguishing features here, and those features will be used by the trained classifier, because now it's know, after training, our model knows that which feature class should be assigned to which class, right? So it will be use its trained models in case of neural network, and then it will give us the prediction of that input sample. For example, if it was a cat, it will tell us that it was a cat. Or on the other hand, if it was a dog, it will tell us that the label of this image is a dog. So this is a one simple example. So this is a very generalized pipeline, and the two phases, one is the training phase, other is the prediction phase, and in most of machine learning application we follow this pipeline, and the workflow remains the same. However, there can be an addition of some other modules within this pipeline, but the major building blocks remains the same. Okay, so now let's have a look at a very interesting and a very good parameter which helps us during the training of our model, our machine learning model. And we will see two important things here. One is the underfitting, and the other is the overfitting of the model. So both of these things, we need to avoid these things during our training, right? We don't want our model to be underfit, and we also don't want our model to be overfit, right? Because in both of these things, if my model is underfitting or my model is overfitting, then the performance of my model on the unseen data will be dropped, right? So we need to tune and we need to train our algorithm in such a way that it should not be underfit or overfit, right? And we can avoid this thing by having the by having an observation on the training graph, right? So you can see that we have an indication of error here, right? Or we can have the number of iterations here during our training phase, right? So the target of the training phase is to reduce this error, and keep in mind that this error, if I talk about the neural network, then this error is basically the difference between the actual outcome and the predicted outcome. And the target is that we want to minimize the error between the two values. We want to minimize the error between the predicted output and the actual output. And if your your error curve is decreasing with each iteration, then it means that you are performing very good in your training phase, and the error is basically decreasing, and you can expect that your model will not be underfit or overfit. Normally, when you provide too much examples during the training phase and those examples don't have enough variation in them, then in that case you can expect that your model will be overfit, right? And an overfitted model performs very well on the training data set, but it doesn't perform well on the testing data set. On the other hand, if you don't provide enough examples during training, then your model will go to underfit, and in both these cases, the performance of the model will be dropped.